Hi and welcome. I'm going to go over question number 6 and hopefully get as many of these done as I can on one video. So let's do it. This is in your book on page 669 and you can look up the answers as well. So question 3.6. Feel free to write out your own explanation or if you want to use mine. So if you missed this question, let's talk about it for a bit. It says, there was an interesting poll online. Anyone can become a part of the sample just by clicking on the response. That sentence right there is telling us that this is like a radio show. Anyone can call in or decide not to call in. So this isn't a random sample where every person had an equal chance of being chosen. That's not this at all. So it says 8,896 responded, and we have no idea how many people chose not to answer. Not that even really matters, because the minute it becomes a voluntary response question, you're looking for voluntary response in your answer choices, and there it is. Okay? Now, the reason why this is a classic issue is because we've seen in the past that if you have a choice to answer, most people that are indifferent choose not to answer it, and the people with strong opinions choose to answer. Whether that means they really, really like it, strong opinions choose to answer. So you're not getting the voice of the public, you're getting the voice of the really, really angry and the really, really happy. Okay. You want to use that when you're a waitress and your comment box has a bunch of negatives in it. You want to say, this is a voluntary response situation. Okay, question number 3.7. The answer here is C, and we're going to walk through that question here step by step. So it says a certain candy has a wrapper, and it's one group, holiday 1 and holiday 2. Pretty interesting question. It's a pure probabilities question, but probabilities is a backbone of statistics. So let's take a look. It says we have a silver, red, and pink. They have a distribution of 30, 30, and 40. So this is reminiscent of chi-squared a little bit. Okay. Now, during the holiday, a different holiday, so this sounds like maybe New Year's or Hanukkah, half are silver, half are blue. Okay. So if you took a sample from this distribution of 40 candies and you took a distribution of 40 candies from this, you should expect different amounts of silver. And in fact, there's a formula that is logical, but also on the formula sheet. So we're going to focus in on these two formulas. That formula, n times the probability, see how it's under the probability part of our formula sheet, and this one, which is the standard deviation, if I'm just doing probabilities. Notice I don't want to grab this one because this isn't a sample, and this would be if it's a pure yes or no answer, so that's the probability of yes and the probability of no. That's not what we have here. Very different formula. You see how that's a different formula? Okay, so we want to grab these two formulas and use them in this problem. So the standard deviation, or the expected value of silver, would be n times p, and so the number of candies is 40, and the proportion that are silver is 0.30, and that's 12. And we could kind of think of that logically. We could think 30% of 40 is 12. Of means multiply. And in the other sample, sample 2, 50% of 40 is 20. So if we think about mu total, it's, sorry, hard to hold the phone and write at the same time. Mu total is equal to the average of group 1 plus the average of group 2, and the average is really the expected value. So we can add those together. Now they're kind of tricking you. So a lot of students want to then add standard deviations, and that's a huge rule in this whole book, is standard deviations can't be added. We can only add variances. Big rule. Okay. It reminds me of our triangle idea, that if I had a right triangle and I went 4 miles and 3 miles and I took a shortcut, I went 5 miles. If I went this direction, I didn't go 4 and 3. I went straight to the 5. Okay? And it's the same exact idea when I want to go adding variances. I can add variances. I can't add standard deviations. That's like adding that number and that number to find that. You can't do it. To do that, you would do Pythagorean theorem. And so kind of in the same idea and the same concept, we recognize this. That's how we're going to add variances. So let's do it. So our formula said the standard deviation of group 1 is the square root of n times p times 1 minus p. Okay, so that's the square root of 40 times 30% times 70%. And the standard deviation of group 2 is slightly different. N is the same, but the proportions are different. So in that sample, half of them were silver, half of them were not silver. So we were told to find, I can add variances. Well, technically the definition of variance is just standard deviation squared. So the standard deviation of the total would be the standard deviation, this would be how we'd write the variance of the total. Now we want to add the variance of the first sample, and we can add the variance of the second sample. And that would be how we could, but it has to be a variance. And a variance is the standard deviation once we square it. Okay, so let's do it. We know that. Some interesting math here. We're going to square a square root, so it'll just go away. And we're going to square a square root, so that'll just go away. And then don't forget, to find the standard deviation of the total, we're going to have to take the square root of our answer. So when I do that, I end up getting my answer 4.29. Bam. Awesome. That's our answer for question 7. Okay, 6 and 7 done. Question number 8. So question number 8 is the answer A, and I think a lot of people got this one right. We've definitely been talking about it. It says if a rancher sampled 42, so that's our N, from a large herd, and he obtained a confidence interval that's 95% to estimate the mean weight of the cows, he observed that interval. And now we want to think about, what if the rancher wanted to do a 98% confidence interval? Well, we know that the formula is this statistic, which that part would be the same, plus or minus our critical value times the standard deviation of the statistic. So this part would be the same, the statistic would be the same. The only part that would be different when we switch from a 95 to a 98 is this critical value gets bigger. And I gave that example of guessing what the weather was going to be like. If I had to guess that today's temperature was going to be 65 degrees, it was cold today, plus or minus 15 degrees. If I increase this margin of error, which is critical value times the standard deviation of the statistic, I am being less precise. And my interval is wider, which is another reason why our answer is A. All right? So feel free to write this if you got the question wrong, or the explanation that makes sense to you. Okay, last one we'll do, and then I'll put the next one on the next video. 39. So our answer for 39 is D. Let's walk our way through it. This is a classic statistic question we may see in the SAT. It says school A has 400 students. School B has 2,700 students. A local newspaper wants to compare their SAT scores. So if we didn't normalize it, B has way more students, and A just has hardly any students. And so I need to make this relative. So this would not be that impressive. This is B and that's A, because that's so many more students. It's like comparing a public school to a private school. However, how we are able is what we're interested in. Well, if 20% of school A got a score of 700 or better, and 20% of school B got a score of 700 or better, then we would want their bars to look exactly the same. That's called, and we'd want the graph here to say 0.2. That's what's called a relative frequency histogram. Okay, and we want them drawn on the same scale. So that's why the answer is D. Thanks for joining us. Check out the next videos up to question 25 to write out your explanations. And as I said, feel free to look in the back for the answers. And if you understand it, write out your own explanations.